Hello everyone and welcome to Causality with Boris, broadcast from SobolevSpaces. Today I want to talk about a big picture, a picture of probability, drawn with your own pencil. Everyone that I meet these days seems to talk about visualization, data visualization, concept visualization. You know, I love giving you practical tips about causal reasoning, and what would be better than learning how to picture the probability itself. In today's lesson I'm going to teach you how to use a mosaic plot for depicting association. But first, let's review how to construct it. Mosaic plot is just a square divided into rectangles, and we use it to present groups. For instance, you can imagine 4 groups in this plot. In mosaic plots, we think with areas instead of counts. Looking at this plot, we can conclude that A is bigger than B. Group B and C are the same sizes, all based on the proportion of space they occupy. 2 guiding ideas here. The square represents the entire population. Areas of rectangles are proportional to group sizes. In probability, we deal with proportions as well. In fact, we define the probability as a proportion. The number of times the desired outcome occurs among all possible outcomes. Think of all possible outcomes as a square with the total area of 1. The desired outcome occupies some space in it. In relation to the whole square, that space is proportional to the frequency of outcomes, and it can be thought of as its probability. To depict probability, we divide the square horizontally in 2 parts. For instance, data from stats department show that almost half of these students have brown or hazelnut eyes. In the plot, that's the area of the bottom bar. The area of the top bar represents the probability of a lighter color. This all may strike you as incredibly basic. Good. Just one more thing. It turns out mosaic plots are a powerful tool for depicting probabilities that involve 2 variables. The power of mosaic plots is in geometry. Areas, heights, width are all meaningful here. Let's see it. When dealing with 2 variables, it's helpful to think of one as an outcome and the other as a group indicator. Say groups could be treated and untreated patients, and the outcome is yes or no for being disease-free. To construct mosaic plot for 2 indicator variables, we first assign each variable to an axis. Top and bottom of vertical axis represent outcome values, left and right of the horizontal axis represent groups. Then we divide the unit square into vertical bars. The width are proportional to overall frequency of groups. Vertical bars could be the same width when groups come from clinical trials. Bars could be of variable width when groups are from observational studies. Their width could be thought of as marginal probability of each group. Marginal here means without considering any other variable. To bring outcome into consideration, let's divide each bar horizontally into rectangles, so that their areas are proportional to relative frequency of groups and outcomes. Area at the bottom left tells us how often we observe members of the treated group with outcome yes. Area at the top right, how often untreated come with outcome no. The areas of rectangles could be thought of as joint probabilities of outcome and group membership. Within each bar, heights of rectangles are simply conditional probabilities of outcome for the group that the bar represents. And we use their heights to depict association between the group membership and outcome. In mosaic plot for 2 indicator variables, we see 4 rectangles. They are drawn by dividing the unit square into vertical bars according to overall frequencies of values on horizontal axis. Each vertical bar is then divided into rectangles. Their heights are conditional probabilities of vertical variable for given values of horizontal axis. In probability theory, we say 2 variables are independent if they don't affect each other's probability. So we check if independence is in place by comparing the heights of rectangles across the horizontal axis. Under independence, the heights are the same. We can say 2 variables vary independently if their mosaic plot is flat, like Windows logo. Variations in height show departure from independence. There are 2 cases here. When events tend to occur together, we say there are positively associated. Their mosaic plot will show a taller rectangle on the left. It means outcome yes is more frequent in treated than in untreated. When events tend to not occur together, we say they are negatively associated. Their mosaic plot will show a taller rectangle on the left. It means outcome yes is less frequent in treated than in untreated. Let's turn to our example of eyes color and now consider it by darkness of hair. We draw the unit square to represent students in stats department. Next, we assign an indicator of dark eyes to axis y and the hair color to axis x. Then we divide these unit square into vertical bars. Their width are proportional to overall frequency of the hair color. On this plot, 1/3 have darker hair and 2/3 a lighter color. Then we divide each bar into rectangles, so that all resulting areas are proportional to relative frequencies of students with various combination of hair and eyes color. Heights of rectangles are probabilities of eye color for a given hair darkness. On this plot, the height at the bottom left is 0.7 and the height at the bottom right is 0.35. We read this as students with darker hair tend to have dark eyes in stats departments, and that's all there is to it. We covered a lot of ideas today. Here's the short summary. To construct a mosaic plot, we draw a unit square. Then we assign outcome variable to axis y and groups to axis x. Next, we divide the square into vertical bars and then divide bars into rectangles. Geometry of rectangles is linked to probabilities. Their width are marginal probabilities of treatments. Their heights are conditional probabilities of outcome for given treatment. We use their height to depict association. Groups and outcomes are independent if their mosaic plot is flat. Variation in heights of rectangles depicts an association. Variation in heights depicts association. Beautiful line. It even beats my weekly horoscope. Venus in somber Scorpio offers some clarity in the relationship. This short summary is still bigger than your screen. You know what? You can get a free PDF worksheet for this video that I prepared for you. Details are in description. In next video, I will talk about depicting conditional independence. That's 3 variables. Keep on watching.